Right, today is day 5 of Unit 4. It is very similar to day 4, Unit 4, but just more examples. Okay, so before we get started, I wanted to talk about day 4's lesson. So if you could turn to page 13, I just have a couple. I talked about this in class, but I just want to make sure that you guys have your notes correct. So again, you're on page 13. I just want you to make sure in day 4's video, I accidentally wrote 1 plus r right here, and then I wrote 1 plus 0.03. This is all right. What I showed you in the calculator is right. I just wrote a plus sign instead. So just make sure that your notes are correct. And again, this answer is what was in the video yesterday. The calculator was correct, but the equation I wrote was incorrect. Okay, so you had to do 6 and 7 on your own, so I just wanted to go over those real quick. 6 was a growth. Okay, anytime you talk about interest, basically, if you have a savings account and you're gaining interest, it's going up, so it's going to be growth. So that would be y equals a times the quantity 1 plus r raised to the exponent of x. So I substituted that all in. Again, it's really important that you guys are trying this in your calculator yourselves and not just copying directly off the video. On the test or quiz, I'm not going to help you. So this is your time to ask questions and to practice. So please make sure you are doing that on your own. Okay, so for that one, Alex would have $25,013.65 in his bank account after 13 years. And then number 7, that was also growth. Keyword right there said increased by 6.5. Please be careful when you guys are converting your percents. Every time they have a decimal in it, for some reason we get a little mixed up. So please make sure, remember, you move your decimal point 2 spots to the left. Okay, so we started at 6.5, so 1, 2, so 0.065 or 65 thousandths. Okay, so again, our equation was y equals a times the quantity 1 plus r raised to the x power. Substitute that all in, and you would get about 905 frogs. Again, the last question, number 6, that was about money. So you just slap a dollar sign on that one, but this one, make sure that you label it frogs. Okay, so now you should be on page 14 for today's lesson. Okay, so our essential question for today is how do we solve problems involving exponential growth and decay? So prior to yesterday's lesson, we talked about the equation y equals a times b raised to the x power. Remember, b is the only thing being raised to that power. So in order for our equation to be exponential, you need to have an x in the exponent. Okay, you need to have that, or else it is a different type of function. Okay, so again, before yesterday, we were talking about our b value. So our b value is our, it's either our growth or our decay. So when we looked at a table on day 3, we were looking for how much we multiply by as we go up. As our y increases, we were looking at how much we would have to multiply to get to the next number. So here, all of these questions, if you remember yesterday, most of them had to do with a percent. Okay, all of them, I should say, had to do with a percent. So when you see a percent, okay, when you see a percent, you should be thinking that, okay, we have a rate, so we're going to have to use one of these two functions, equations rather. Okay, so if your b value is greater than 1, so basically if the term or quantity that's being raised to the x power is bigger than 1, it's going to be growth. If it's smaller than 1, then it's going to be a decay. So we're going to take a look now. We're kind of going backwards from yesterday. We're already going to be given not for all of them, but for this first one, we're going to be given a function, an equation, and we have to figure out if it is a decay or if it is growth. Okay, so if you look at number 1, okay, and again, I'll just write this up just so you can see. So y equals, I'll just write abx, okay? ab to the x power. All right, so this is my a value, this is my b value. Okay, so clearly I can see that b is less than 1. Okay, so this is going to be a decay. So, let's see. V of x is, let's say modeling. Let's take out is. Okay, don't have a lot of room. Okay, so V of x models exponential decay because b is less than 1. Okay, simple as that. Alright, so now we want to know, to the nearest dollar, how much more is a car worth after 2 years than after 3 years. So basically all they want us to do is they want us to substitute. Okay, but it said how much more. So this to you should be shouting out, okay, I'm going to have to find the difference between the two. Okay, now these right here, okay, these are taken right off Regents questions. Okay, the people that write the Regents questions, they're not dumb. They, unfortunately for you, they put distractor answers purposely because they know the types of mistakes you're going to make. Okay, so it's really important that you guys underline everything that you think is important. Okay, so please just take the extra time to do that. Okay, alright, so all I'm doing here is I am substituting for, so remember my x, my exponent, this just represents the number of years. Okay, and I'm going to say more often than not, that is what it represents. Okay. Alright, so if I plug all of that into my calculator, for 3 years I would get 15,901 and 40 cents. And I got 18,490. I think I got a whole number for that. Okay, so the important thing to remember now, it might, a way to check that you put this in correctly, this is a decay. So at 2 years, it should be higher than at 3 years. Okay? Alright, so now the last step we're going to do, so notice both of those answers are right here. So if you don't read the question, you're going to get it wrong. Okay? 90 minus 15. Okay, so if you subtract those, you will get 2,500 and I think 88 and 60 cents. Okay, so to the nearest dollar, that would be choice A. All right. Next one. Okay, the table below shows the average yearly balance in a savings account. Interest is compounded annually. Okay, so that just means that it happens once a year. Okay. Okay, so that's just per year. Okay, so no money is deposited or withdrawn after the initial amount. That's important. Which type of function best models the given data? All right, so let's see. The first thing we're going to do, okay, so we know that this is going to be exponential just because these types of questions are exponential. Also, if you look, to get from one to the next, okay, so just to rule out, this would be $182.49 to get to that one, if I'm adding. This one would be $270.14. Okay, so it can't be linear. Can't be linear. So basically, all I'm doing, okay, as the years get higher, the money gets higher. So easy enough. That would be growth. Okay. So balance is going up. Right, so it's got to be growth. And again, you should just be able to tell that that's exponential just based on the type of question it is. All right, James was given $3,000 when he turned 2 years old. He invested at a 2% interest rate. Okay, so this is going to be A. Okay, 2 years old. So this is going to be the starting point. So not at 0. This will be our, so 2% equals 0.02, and then annually. Okay, so each year. Which expression can be used to determine how much money he will have when he turns 18? So the first thing we have to do is, okay, so x is going to equal 18 minus 2. Okay, so right off the bat, I could take those off. All right, and then I can look at this and see, okay, well, it's interest. Okay, so if we have interest equals growth. Okay, that's just, you should know that. Okay, so our answer is A. Easy as that. All right, so again, we are trying to, again, go backwards from what we were doing yesterday. So they're giving us a function, and we need to pull things from the function. Okay, so let's see. So we have our function right here. We know this is A, and then this is saying B is greater than 1. Okay, so this means that we would use okay, so since B is greater than 1, that means we're going to use y equals A 1 plus r to the x power. Okay, so we want to know the yearly rate of appreciation. So this means growth. Appreciation means growth. Okay, so all we need to do is we need to figure out the percentage. Okay, so I need to use my B. So all I'm going to do is I'm going to take that part of the equation and I'm going to solve. Okay, so if I have, so 1.017, so if I subtract 1 from both sides, I know that R is equal to 0.017, which as a percent, okay, remember 1, 2, is 1.7%. Choice C. Okay. And then again, we pretty much already answered this. Does this model a growth or decay? Oops, sorry. Turn that into a G, that look ridiculous. Okay, so growth because B is greater than 1. Okay? All right, question number 6. Brendan invested, where are we? Brendan invested $600 in a savings account at a 1.6% interest rate. Annual interest rate. Okay, so I know this is A. R equals 1.6%, which is 0.016. He made no deposits or withdrawals for the account for 2 years. X. The interest was compounded annually. They already said that. Find to the nearest cent the balance in the account after the 2 years. Okay. So first thing we have to do is we need to write our equation. So it's interest, so it's going to be growth. So A equals 1 plus R raised to X. And then it's just simple substitution. Again, the biggest thing to remember, the biggest mistake that students make is not to change that percent into a decimal. Remember, we don't deal with anything that is not a decimal. Okay, so when I put that into my calculator, I got 619. And I got, what's that? 3536. Okay, so it's going to be 35 cents. All right. Please remember to look at your units. All right. I mean, it's money, but you never know. Maybe they'll ask you for the nearest dollar. So please make sure you guys are paying attention to that. All right. Okay, so I would like you to do number 7 on your own. You can use, let me see, use number 1 to help you, okay? Use number 1 for help. Okay. And and I'm going to have you do number 8 as well. Use number use number 5 for help. Okay. And I don't know how this happened, but I think I skipped number 4. So let's go back and do that one real quick. Okay. Let's take a look at it. All right. You know what? Do number 4 as well. You can do number 4 as well. For that one, you can use number 6. Yeah, use number 6. Okay? And really, that's from yesterday. Okay? So, again, on your own, do numbers 4